Try it again. We'll try negative 1 now. When I do negative 1, 1 comes down. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. Negative 5 plus 2 is negative 3. Negative 1 times negative 3 is 3, and those add up to be 0. That worked. Okay? That tells me, let me go back over here. That tells me that this is x squared, and then what? Opposite of this number, x plus 1, and then what's here? Use these numbers, x squared minus 2x minus 3 equals 0, right? Yeah? Now this hopefully factors. It does, right? It does. But we could do synthetic again, couldn't we? Yes. But it does factor. So I'm just going to go straight to it. See, in my other class, I would not expect them to be able to get this like right away. I'd expect that they have to do quite a bit of work to do this. But here I am expecting that everyone would be comfortable with this. That's how it factors, right? X minus 3 times x plus 1. Do y'all see something important? What do you see?
What bouncing across it?
Yeah, you see the x plus 1? There's 2 of them, right? 2 factors of x plus 1. Everyone see that? We need to make sure we're going to do that. If we're going to use that whole bounce cross thing, we better do that. So I'm going to do x squared, x plus 1, that quantity squared, and then I have x minus 3, and then equals 0.
And then since the first one is x to the 5th,
Yes.
it opens up going down.
Goes like this, yeah. So this is where you have to make a decision. Do you want to do the test points, or do you want to use the graph? Totally up to you. I don't care, all right? I'm going to go ahead and do the number line at least. I'll do that much. I'm going to draw my number line. I need my points, so set these equal to 0. You get x is 0 here, right? X is negative 1. That's from this one. And then x is 3. Right? And while we're here, if I draw it, what am I going to do at 0? Bounce or cross? Bounce, right? Because I have a 2. Here, I have a 2, bounce. And then here, I'm going to cross, right? OK, but let me put these points here. I have 3 here. Right? I had 0 and negative 1. So like I said, you could do test points at this point, right? You could do test points. Or let's just use what we know about the graph. I'll do the graph in a different color, in red. If I were to just use that information, I know I've got these x-intercepts, right? I know the left side goes down and the right side goes up. I know that because the degree of the polynomial was 5, right? And the leading coefficient was 1. So I know it does this. And then I've got to bounce off here and bounce off here and cross here. So it goes up, it bounces, bounces, crosses like that. So that means if you had done the test points, would this have worked? No, because we're trying to figure out where this thing is what? Greater than 0, right? And this over here, the graph is below. Would it have worked here? No. Here? No. Here? Yes. So only to the right of 3. Do we include 3? No. So my answer would be parentheses 3 to infinity, done. Questions, comments, concerns, complaints, gripes? Just want to bitch about something? Yep. Yep.
How did we know what points to include while looking at the graph?
Do you mean these?
Yeah.
Those came from our x-intercepts.
Yes. How do I know if they worked or not?
If these numbers don't work, these numbers give you 0, right? We could have tested a point over here, -2, to see if it works, right? But we're not even testing it because this is the graph of that, right? This is the graph of that. So if we want to know where that graph is bigger than 0, that means we're saying where's the graph above the x-axis? Do you see this red is below? It's negative, right? I need it to be positive, greater than 0, so it doesn't work. So I'm testing it by just looking at the graph. Okay, I want to change the problem. What if I change this, and now I have a bar there? Which means I have a bar here, right? Which means now I want to include what?
-1.
I want to include this, right? I want to include this. I want to include this, right? And I want everything this way. You're going to do, yeah, you're going to do, this right here is an interval. Let's do that one first. That's this to infinity, right? And then union. But these are single points, aren't they? And when you have a single point, we don't use an interval, we use the brace, right? So the way you do it is this. Brace, -1. You can just do -1 separated and do another union and do 0. That's completely fine to do them separate like that. Or you could also put it like this. Those are both acceptable. This means a set of answers, -1 and 0. This means the set -1 and then also the set, the number 0. So these two things mean the same exact thing. So you see again how putting this here changes a lot of things in terms of domain? Yes?
Are you thinking about what order I put it in?
No, the order is irrelevant. All right, good? We're halfway through class. I want to go another 20 minutes. That'll save us a little bit of time to talk about the test. We're going to now transition into rational inequalities. Okay, these are harder. Only because there's something else we have to pay attention to. Yes? This is not going to be on the test. Yeah. Not on this test, right? On the next one. All right, let's try a rational inequality. So here's the deal with the rational inequalities. And let me take one step back. When we just did polynomial inequalities, I think what I did is I first showed you that we do the same approach for each one, right? We convert it, we move everything over, we set it equal to 0, right? We try and factor that out. Then we did a number line, and then we did test points, right? And then I showed you, hey, look, if you actually know what the graph looks like, you can do this without the test points, right? I can do the same thing with this. But do we all agree rational functions are more challenging to graph than polynomials? So most of the time, we will not do the graph of this to get the answer. We will just do test points.
Is that easier?
It's easier usually because, remember, what do you have to do for a rational function? You have to find the x-intercepts. You have to find the vertical asymptotes. You have to find the horizontal asymptote. You have to draw it. You have to pick test points, behavior, right? All this stuff. Like, do we really want to go through all of that when we could have just plugged in test points? Probably not, right? Okay, so let's do our first example. Let's do this. X plus 1 over x minus 3 less than 0. Okay, what has been the technique so far? First step. Everything moved over, you get 0, right? Yes? And then set it equal to 0. We're still going to do that step, okay? We're going to set it equal to 0. Okay, we're still going to do that step. But how do we do this? How do you figure out when a fraction is 0? So this is a side note, but a big note. Okay, this is really important. Let's say you have a fraction. set equal to 0. Any fraction ever equal to 0. Do you all agree that I could always just multiply both sides by b? Yes? And what would happen? Over here you get what? Cancel, you get a. And over here, what's 0 times b? 0. In other words, if you ever want to know when a fraction is 0, if you ever want to know when a fraction is 0, it really reduces down to knowing what? Just when the numerator. Just when the numerator is 0. Let me say this again. If you ever want to know when a fraction is equal to 0, all you need to know is when the numerator is equal to 0. Okay? The only way this fraction can ever be 0 is if that top is 0. All right? So what I'm going to do now is I'm going to just set the top equal to 0, and then I'm going to solve that. I get x is negative 1. Okay? That is an x-intercept, right? Now, with the previous polynomial functions, this is where I would go to the number line and put that there and do test points, right? With rational functions, you must pay attention to also the denominator. The denominator, remember, were our vertical asymptotes? We could possibly have a vertical asymptote which would change the behavior of the graph. So we need to also set that equal to 0. And that gives us 3. So yes, at the end of the day, with these, what we're going to do is we're going to set the top equal to 0 and the bottom equal to 0, and take those and put them on a number line. But the reason we're doing that is different. The reason we're doing them is different. There's a different idea behind each one. This is the number that makes this thing equal to 0, right? This is the number that makes this thing undefined. So we need those are important points on our number line. I put my 3 here. I put my negative 1 here. That breaks up my number line. And I pick test points. Let's go with negative 2. Let's go with 0. Let's go with 5. You ready to test them? Good. Let's test negative 2. Where am I plugging it in? Original inequality. So negative 2 plus 1 over negative 2 minus 3. Is that less than or sorry, not less than or equal to. Is that less than 0? What's your numerator? What's the top? Negative 1? Bottom? Negative 5? You have a negative over a negative. Positive. Is 1/5 less than 0? No. That doesn't work over here. Okay? Now let's test 0. I'll test it right here. If we test 0, where am I going? Into this, right? Right here. I get 0 plus 1 over 0, take away 3. Is that less than 0? This time, yes. You get 1 over negative 3 less than 0. Yes, that's a negative number. Negative numbers are less than 0. So that means this works. And if you test 5, it will not work. I'll squeeze it right in here. Test 5. You get 5 plus 1. Is that less over 5 minus 3? Is that less than 0? You get 6 over 2. Less than 0? No. 3 is not less than 0. That one didn't work. Oh, wait. This one did not work. Yeah. OK, so that means no here, right? Good? All right, so I know right now that everything in between here works, right? Do I want negative 1? Well, negative 1 is what made this thing what? Equal 0, right? So do I want equal 0? No. So I don't want negative 1. Do I want 3? No. And in fact, even if this had a bar, pay attention, even if this had a bar, even if it did, right? Even if it had the equal bar under this, I would still not want this 3, would I? Because it makes it undefined. Okay, now I'll show you with a different example. But I don't want 3 here, so my answer is just everything between negative 1 and 3. So negative 1 to 3, parentheses on both ends, we're done. I'm gonna try this. Let's see how this works. if I adapt the problem here in green, and I did make that have a bar, right? We'd still do this. We still set it equal to 0. We still set the top equal to 0. We still figure out what makes the bottom 0. We still do our number line. We still do our test points. Everything works the same. When we get to this right here, you know, the no, yes, no, do we want -1? Yes, this time we do, right? We do want it because that makes it 0. So we would include it. I'll do it above it. We would include it this time, right? It would be everything in between. But the 3 we still don't want because it makes it undefined. So we would leave it open. And so our answer, if we had a green bar under this, would be -1. Oh, wait, bracket, sorry. Bracket on the -1 to 3 parentheses. So basically, when it comes to rational inequalities, anywhere that you have a vertical asymptote, anywhere where the denominator is 0, or anywhere where you might have a hole, you would throw it out. Let's look at, I like 39, looks pretty good. I'm going to do number 39. Even though that's one of your homework problems, I'm going to do it. We're going to do 2 more, and then we'll call it at least we'll call it for this, and we can talk about the exam. All right, so now let's do x minus 3, that quantity squared, over x squared minus 4. And I want to know when this is greater than or equal to 0. All right, well, it's a rational inequality. So I want to make sure everything's moved over to one side. I have 0 on one side, right? Change it to an equation. I'm going to stop changing colors. I hope that's OK with everyone. Change it to an equation. And then I have 2 things to look at. First, what makes the top 0? So set the top equal to 0. Bless you, by the way. And so I just took the numerator, set it equal to 0. Well, is that obvious what x has to be to make that 0? 3, right? X is 3. OK, and then I also have to look at the bottom. That's where I'm going to have vertical asymptotes, right? Possibly. So x squared minus 4 equals 0. That's a difference of squares. X plus 2x minus 2 equals 0. And then I have 2 solutions here, -2 and 2, right? And remember, these, I'm going to omit these no matter what, right? No matter what, these will never be part of my answer, right? Will this 3 be part of my answer?
Yes.
Yes, because this is what makes it 0, right? And this time I do want it to be 0, right? So I want to include that. That's just me thinking ahead here. Let's do our number line. All right, I've got 2 and -2 and 3. Partition the number line up. And now some test points. -3, 0, 2.5, 4. And I'm going to plug those into, test those into the original inequality, right? Into the original inequality. Hey, what can y'all tell me about the numerator?
It bounces.
It does bounce. That's if it was polynomial. Remember, rationals are a little different. I'm talking about the numerator. Is it always going to be positive, negative? Can you tell? No matter what I ever plug in here? It's always positive, right? Because I'm going to square it, right? Just, I mean, I could use that if I want, but let me just test them. Let's see. Let's test -3. Here we go. So we go -3 minus 3 squared over negative 3 squared minus 4, is that bigger than or equal to 0 is the question. So up top, what do you get?
36.
You get negative 3, take away 3 is negative 6, squared is 36. So you get 36 on top. On the bottom, negative 3 squared is 9. 9 take away 4 is 5. Is that true? That's a positive over a positive. That's positive. That's greater than 0. So this works. Let's see. All right, let's plug in 0. Let's plug in 0. I'm trying to find space here. Testing 0 now. So we get 0 take away 3 squared over 0 squared minus 4. Is that greater or equal to 0? The top is positive, right? No matter what? What's the bottom? Negative. Positive over negative? Negative. So that's not true, is it? You'll follow? So no? Okay, what about 2.5? Let's test that. I'm going to do it right here. Let's test 2.5. 2.5 testing, and we've got 2.5 take away 3. It's not going to matter. I'm squaring it. And then I have 2.5, and then that squared minus 4. Is that greater or equal to 0? Yes, because this, again, is always positive, right? And then 2.5 squared, I know, is bigger than 4. So I know that's a positive number, so this is true. And then we try 4, right? Try 4. So we get 4 take away 3 on top, right? 4 take away 3 squared over 4 squared take away 4. Is that greater than or equal to 0? That's positive. And then 4 squared is 16. Take away 4 is still positive, right? So that works still, right? Okay. All right, let's try and summarize our answer here. I know right now it's going to be everything to the left of negative 2 forever. I know negative 2. What?
Sorry.
Okay. Everything between 2 and 3 works, and everything past 3 works, right? Okay, do I want to include negative 2?
Yeah, no.
No, because that causes division by 0. So I'm going to throw that out no matter what. Do I include 2? No, that causes division by 0. Do I include 3?
Yeah.
Yeah, because 3 is what makes it 0, and I want it to be equal to 0. See, so the common mistake that students make, as you might imagine, is that they see a bar and they include all these points. They say, oh, I see a bar, so I'm going to include this, include this, include this. It's not the case. Not with rational. You have to pay attention to what's going on. So there we go. That's it. So that means everything to the left of negative 2, not including negative 2. Then everything to the right of 2, just keep going, right? Just keep going. So left of negative 2, like that, not including it, union. And then from 2 on, don't include it, and that will pick up the 3. This will pick up the 3. You don't have to do 2 separate ones. You can do it all in one. Okay. Doing all right? Yes?
Why are we omitting the negative 2?
What would happen if I ask you to plug 2 into this right now? Just plug 2 in. Because if you're saying 2 is part of your answer, try and plug 2 in and see what happens. 2 on top, you get a number, right? But what happens when you plug 2 in right here? 2 squared, 4 minus 4. You get division by what's that? It's undefined, right? You can't tell me that undefined is bigger than 0. So anywhere that the denominator would be 0, we have to chunk those answers, get rid of them, all right? Okay, one more. And if you understand this and you're good and everything, please pay attention to this one, all right? Because this one is usually a test-like problem, and students they get ahead of themselves and they get overconfident and they make mistakes. So I'm going to do the last one, 42. X plus 2 over x minus 4 greater than or equal to 1. All right. What's new? What's different? You have a 1 there, not a 0, right? We have a 1 there, not a 0. We have to have a 0 there to use this method, which means you're going to have to move that 1 to the left side, right? Which means you're going to subtract 1 on both sides. Let me do that. This is what it looks like. Okay, there.
Can't we just make that look better?
Well, we're going to have to deal with that left-hand side, right?
Yeah.
So let me now convert it to an equation. Okay, I'm converting it to an equation. And now what I'm going to do, and this is the step that students miss, is I'm going to put these two fractions together into one fraction, which means I need a common denominator. So I'm really looking at this as being x plus 2 over x minus 4 minus 1 over 1 equals 0. And now I need to get a common denominator and combine those. The common denominator will be what? X minus 4, so I have to put an x minus 4 here and an x minus 4 on top. I turn the 1 into x minus 4 over x minus 4. Now they have the same denominators, right? So you can put them together. So when I put them together, let me go really slow because it's been a while since we've done this. This will become that minus, now I have the x minus 4 here over x minus 4 equals 0. Because they have the same denominators, I can combine them into one fraction, x minus 4 on the bottom. But on top, I'm going to do what? X plus 2 minus this, right? Which means it's going to look like this. X plus 2 minus the x minus 4. You have to subtract the entire numerator of the second fraction. You can't just throw a minus sign here without this parenthesis. That minus must distribute through to both of those. So it becomes x plus 2 minus x plus 4 over x minus 4 equals 0. You all with me? You'll see that minus plus, minus plus. What happens up top? We just get what? 2 plus 4, right? That's it. The x's cancel, right? So you just get 6 over x minus 4 equals 0.
That's the answer.
No, that's not our. This is the thing we're going to look at.
6. What is it?
Yeah. So now, first thing we want to do is we ask ourselves, when can a fraction be 0? Only when the top is 0, right? So you take the top and you set it equal to 0, and you say what? Yeah, no, right? That doesn't, see, there's nothing you could ever plug into this that's going to give you 0. There's no x-intercept, exactly. There's no x-intercept. You know, good? Okay, so this right here, we don't have any answers, but we still have to take a look at what? The denominator. We have to figure out what we're going to throw away, right? What answer we're going to omit, and then here we get what, x is 4? We want to make sure that we omit that answer, because x equals 4 would actually cause a major problem in the very beginning, right? Would have caused a problem. So that means when I go to do my number line, I'm only going to have one number on it, right? 4 is the only number I'm going to have on it. So I put on here 4. That breaks up my number line into 2 pieces. Let's go with 0 and let's go with 5. And I'm going to test those where? Right before I turned it into an equation. Right here. I'm going to try it. Yes?
If there's no x-intercept, wouldn't you be able to just test 0 and see if it's positive or negative? Because it wouldn't be.
You can have an x-intercept. To change it doesn't have to have an x-intercept. Like to go from positive to negative, it doesn't have to, because it could be a vertical asymptote there. It could be like we graph rational functions where we have vertical asymptote, and it does on this side it does something like that, and on this side it does something like that. So to the left it's negative, and to the right it's positive. So you have to check them both. All right, what happens when we plug in 0? If I test 0 into this, I get 0 plus 2 over 0 minus 4 minus 1, is that greater than or equal to 0? You have to calculate this. This is negative 2, well, negative 1/2, right? 2 over negative 4 is negative 1/2. So this is negative 1/2. Take away 1, is that bigger than or equal to 0? No, because that's a negative number, isn't it? Negative 1/2, take away 1, negative, no, that doesn't work. So that doesn't work, right? And then you plug in 5. If you plug in 5, you get 5 plus 2 over 5 minus 4. Is that greater than or equal to 0? 7 over 1. True, right? Oh, I forgot the minus 1. Thank you, thank you. Yes, that's my mistake. Minus 1 greater than or equal to 0. So this is 7, right? Take away 1 greater than or equal to 0. That's still true, though, right? So that means it's true, which means the solution to this, oh, do we include 4? No, we don't include 4, right? So it's only to the right of 4 forever, this way, not including it. 4 to infinity. Okay, I think that's going to be it. I want to show you all something here. Here's my Cal 3 exam that I just gave last week. Okay, so I want to show you number 2 on their exam. Oh no, not number 2. Where is it? Number 3? No, not this is Cal 3. There we go, right there. Okay, so in this problem, you had to they had to find the domain of a function. What I'm getting at, okay, the only reason I'm showing that to you is because to solve that, they had to solve 2 things. They had to figure out when this was true, and they also had to figure out when this was true. Strictly greater than 0. Okay, these are inequalities, right? This is a linear inequality. Linear because these are both to the first power. You got 2 variables in here. Here, this is a quadratic inequality, right? The method to solve these is pretty much the same thing that we just did, okay, where you have to do test points. Take this, set it equal to 0. Okay, set that equal to 0. Now just move them over. You get y is x. What does that look like? If I gave you the function, if I said instead of y, I said f of x equals x, you all know what that graph looks like? F of x equals x? It's the diagonal line, right? So what we have here is the diagonal line. And it's either, to do the inequality, it's either everything above this line or everything below this line. And so what you do is you pick a test point, a literal point in space, and you plug it in here and you see if it works.